I came to tour in January 68 in the department of biophysics, headed by Thérèse Plagnol, who came at the same time from Paris. She was the first woman in the world to work in nuclear medicine, and she was very interested by the ultrasonic techniques for echoencephalography and Doppler, of course. That's why she was interested to me in his group in Tours. So I could, in the beginning of '68, improve very much the machine in order to have a directional Doppler system, which has been commercialized immediately after our. It was named De Lalande Electronique. De Lalande was a pharmaceutical company who experienced this machine frequently for testing the vasodilators they were developing. So they were interested to use Doppler to see how much the circulation was increased using the Doppler system. The major applications were on the carotid and vertebral arteries, and also for arteritis in the lower leg and upper legs. So peripheral vessels in terms of physiology. Of course, the problem was at its time to measure velocity in the vessels. We did not know the angle of the Doppler, so we could not give the values in centimeters per minute, cubic centimeters per minute, or centimeters per second. So we had just the velocity curve, and it was important to find an index or something to reflect the peripheral resistance or blood flow. So we determine a ratio, which is called we called it a resistive index. This is a variable part of the velocity curve divided by the total curve. So this value is increasing when the resistance increases and decreasing when the resistance decreases. So we have called it resistive index or resistance index, and now it is called Pourcelot index worldwide.